Hey everyone! This is Gayatri from Youthbuddy. Dear students interested in assembly programming, tuning in. Learning assembly step by step helps you understand computer hardware, low-level programming, and system-level software with confidence. Here's something helpful for you: Assembly Programming Skillset Learning for Students from Youthbuddy. Assembly is a low-level programming language that provides direct control over computer hardware, making it essential for system programming, embedded systems, and performance-critical applications. Unlike high-level programming languages, assembly works much closer to machine code, helping you understand how processors execute instructions and manage hardware resources. Strong knowledge of computer architecture, logical thinking, attention to detail, debugging skills, and an optimization mindset provide an excellent foundation for learning assembly. Begin by learning assembly syntax, binary and hexadecimal number systems, data representation, registers, memory addressing, and simple program structure. Understand how assembly instructions map directly to CPU operations while writing simple programs that perform arithmetic, loops, comparisons, and basic output. Continue by exploring general-purpose registers, the instruction pointer, stack pointer, base pointer, and the flags register to see how processors manage program execution. Learn how data moves efficiently between registers and memory while using registers to improve program performance wherever possible. Study the instruction set architecture by understanding data transfer, arithmetic, logical, control flow, string, shift, and rotate instructions. Practice using important instructions for moving data, addition, subtraction, comparison, jumps, procedure calls, and program returns to control program execution effectively. Build a strong understanding of memory by learning immediate, direct, indirect, and indexed addressing modes, along with stack and heap concepts. Develop modular assembly programs by creating procedures, passing function arguments, managing stack frames, and working with local variables. Learn low-level input and output using disk operating system interrupts, Linux system calls, hardware input and output ports, and basic console communication. Become familiar with assembler directives such as EQU, DB, DW, and DD while learning macros, procedures, and include files to create cleaner programs. Once you are comfortable with the fundamentals, strengthen your debugging skills using assembly debugging tools, debugger software, and Nazm development techniques. Study code profiling, register allocation, and loop optimization techniques to improve the speed, efficiency, and size of your assembly programs. Explore how assembly continues to play an important role in embedded systems, operating system kernels, bootloaders, BIOS programming, reverse engineering, malware analysis, and security research. Continue strengthening your low-level programming knowledge, debugging abilities, and understanding of computer architecture through practical projects. Mastering assembly prepares you for careers in embedded systems, operating systems, firmware development, reverse engineering, cybersecurity, and performance-critical software development. Stay tuned for more useful info. For more details, click the link in description or explore it directly in the education section on the Youthbuddy website. Like, share, subscribe, and follow our social media accounts for more updates. Yours Gayatri from Youthbuddy, signing off.